Okay, everybody, we're going to look at the, ooh, geez, I got my head off. We're going to look at trig ratios in the unit circle. So we've talked about the unit circle, and we've talked about angles of rotation so far. So we said if we rotate anywhere, right here, we end up, let's say I rotated to this spot right here, boom, right there, okay? So we know that this x and y, or this thing is x squared plus y squared is equal to 1. We know the equation of the circle is x squared plus y squared equals 1. So I want to know, what is this x and what is this y? Can I predict that? Can I link that up between the angle of rotation and that x and y coordinate? Can I connect those? Okay, the answer is yes, and trig is the connection. Whenever I rotate somewhere, I create a right triangle, whoops, sorry, with the x-axis. That right triangle, to get to this point, I could either take the radius out to that point, or I could go out an x value and up a y value. So I can describe that point a couple different ways. Now, right now, I know that this radius on a unit circle, since we're talking about a unit circle right now, I know that radius is equal to 1. So on this circle, how can we figure out what the x and the y coordinate are? How are they related? Okay, well, I'm going to say the angle of rotation is theta. Right there, that's the angle of theta. And what do I know about theta and right triangles? Well, let's see. If I look at this, I can say that this distance right here, is the x coordinate. That x and that x are going to be exactly the same. And I know this distance right here is going to be the y coordinate, because it's how far up we went. You know, we went out and up to get to that point. So y, that's the measurement. That's the measurement there. So now let's bring in trig. Okay, we see that the sine, and in fact, let's even get off the unit circle. Let's just make this r squared over here for any circle that's centered at the origin. For any circle that's sitting at the origin, that's just r squared. So I'll put this as r there. Okay. Now let's check out, what does trig tell us about this? Well, let's see. Back in geometry, we remember that the sine of an angle on the sine of an acute angle on a right triangle is equal to the opposite side divided by the hypotenuse. We knew that from before. So on any right triangle, we knew that was true. Okay, so now if we go over here, what is the opposite side? The opposite side is whatever the y distance is. It's this length y. And what is the radius? It is, or sorry, what is the hypotenuse? It's the radius. So it turns out that the sine of theta is equal to y over r. When we put the triangle into the unit circle. And let's see, what about the x? How's the x related? You got it. The cosine of the angle is the adjacent divided by the hypotenuse, which is, let's see, the adjacent to this would be x and the hypotenuse would be r, so that's x over r. So if I want to link up that angle of rotation to the, to the x and y coordinate, I can do it with sine and cosine. Now it turns out that it's okay. It works even in every other quadrant as well. Okay, and I'm going to talk about this in a later lecture that you're going to watch, but I'm just going to talk about it briefly right now. Even if I got into this quadrant over here, what if I turned my spinner all the way over to this quadrant? So let's say I'm going right there, R. Well, that angle still makes a right triangle. That still makes a right triangle. That's right here. It's got a y coordinate. It's got a y distance, and it's got an x distance right here. So there's my y, there's my x. So there's y and there's x. Okay, and we just said that, now I'm going to make a leap here for you. We said that the sine of theta is equal to, the y coordinate over the r. And that's true. It's the y coordinate over the r. And the cosine of theta is equal to the x coordinate over the r. Same on this one too. All right. So what's interesting here is that we can see that the x coordinate in this case would be negative. So if you take the cosine of an angle in this quadrant, of an angle that's bigger than 90, you're going to get a negative value. You may have remembered seeing that a little bit in law of cosines in your past. So now let's look over here at this one. Let's say that I have a point let's say that I have rotated my spinner to right there. And I know that this point right here is at negative, let's say -3, comma, 6. -3, now 6, no, -3, -2, -2. -3, -2. Great. So what do I know? Well, I know that the sine, this is my theta right here. The sine of theta is equal to the y coordinate over the x, or over the radius. Well, let's see. The y coordinate, I know that's -2 over the radius. I don't know what that is. I said that it's not the unit circle anymore, and we kind of know that because it's not 3, it's not, this is already bigger than 1. Okay, so we can't have that. So let's see. Let's go and what can help us here? What can help us? How could we figure out, let's just erase some stuff here. How could we figure out what that is? Well, look at this. We know that x squared plus y squared is equal to r squared because any point on this circle has to fit in that equation right there, the equation of the circle. So let's see. That means that -3 squared plus -2 squared is going to give me my r squared. Now, some of you might be saying, well, silly, why don't you just use the Pythagorean theorem? But remember, the equation for a circle is really just the Pythagorean theorem anyway. So this is 9 plus 4 is equal to r squared. So let's see, r is equal to the square root of 13. So this is the square root of 13. So the sine is -2 over the square root of 13. So the sine of theta is equal to -2 square root of 13 over 13. I wonder if you can see that. Yeah, I kind of barely. Let me slide you over a little bit. There we go. Okay. So, all right. So then what's the cosine? Once I have that piece, I can come up with the cosine pretty easily. I had to use the equation, remember the equation of the circle or the Pythagorean theorem, to come up with the radius for that circle. Now, the cosine of theta would be the x coordinate, so -3 over the radius, square root of 13. So that's -3 square root of 13 over 13, just like that. Okay, so how else could this play out? Okay, here's another question type thing that we can actually do. Let's say that we know, you've seen questions like this before. This is on the ACT all the time. And you've always built the triangle. There we go, there we go, there we go, there we go. Okay, so you take this, okay, here's this guy. Let's rotate into this quadrant. Well, we don't even say that. I'm just going to say that the sine, we know that the sine of theta is equal to -1/7. Okay, well, how can we interpret that? Okay, how can we come up with what that looks like? Well, there's two ways that we can come up with what that looks like. Okay, we can assume this -1/7, we can think of this -1/7 as the y coordinate is -1 over the radius is equal to 7. We could think of it that way. So then that would mean on this circle, the x squared plus the y squared would have to equal 7 squared. Everybody good with that? Okay, so now the other way that you could think of this is down here, we could say that the y coordinate is equal to -1/7 and the radius is equal to 1. So, oh, I'm back in. So I don't know what just happened there. Not sure, but maybe you guys are all, maybe you were with me the whole time and I'll have to trim that out. Okay, so again, after that little glitch there, let's make sure we got sine of theta is equal to -1/7. That's what we're given. They told us, somebody told us that, and we can interpret that in a couple different ways. We can interpret that as the y coordinate being -1 and the radius being 7, or we can interpret the y coordinate being -1/7 and the radius be 1. We can interpret it both ways. On this circle, that means that this would be the circle where we interpret this as a -1 y coordinate and a radius of 7. So this point over here would be 7, 0, something like that. Okay, and then if we do this one, then we could figure out the x coordinate to that point. But the problem is here, if they don't tell us anything more, they used to be able to just tell us this, and we used to be okay in a right triangle. They'd say theta was an acute angle. But in this case, we know that theta could live in two different spots because there's a y coordinate of -1 in two different spots on this circle. So they're going to have to tell us where theta lives. So what they're going to do is they're going to say that theta lives between maybe they'll call this 180 degrees and 270 degrees. So they'll narrow it down for us, and they'll say it's got to be in quadrant 3, or they'll just say quadrant 3 or something like that. Okay, so now I've got this little guy right here, and I know that the y coordinate for this spot is -1. Okay, if you want, you can build your triangle right here. You can try to, you know that this is 7, you know that this is 1, and you can use the Pythagorean theorem. But we know that this is the Pythagorean theorem set up for us already. So I'm just going to put that in. I'm going to say the x squared is plus the y squared. The y squared is going to be 1 is equal to 49. So that means that x squared is equal to the square root of 48. Square root of 48 is the same as the square root of 16 times the square root of 3. And the square root of 16 is 4. So x is equal to, I took square root of that side. X is equal to 4 square root of 3. And because we're in this negative quadrant here, we know it's -4 square root of 3, like that. So then what we can do, once we know the x coordinate, we can say that the cosine of theta is -4 square root of 3 over this, the hypotenuse, or the radius, which is 1. Over in this one, it's a little bit different. We'd still kind of have the same spot, but now this point over here is 1, 0. It's a radius of 1. So I know that's 1 right there. And the y coordinate is -1/7. So the equation x squared plus y squared is equal to, well, not y squared anymore, -1/7 squared is equal to 1 instead of equal to 7, because we've got a radius of 1. Now we're going to say x squared is equal to 1 over 49, or sorry, plus 1 over 49 is equal to 49 over 49. So that tells me that x squared is equal to 48 over 49 when I subtract my 1/49 from my 49/49. And then x is equal to the square root of 48 over 49. And really it's plus or minus, right? We don't know which one it is, plus or minus. So this is equal to, again, square root of 48, which is 4 square root of 3, plus or minus 4 square root of 3 over 7. So again, that plus or minus taking the square root comes in handy here. Because we're in quadrant 3, we've got a negative x coordinate, -4 square root of 3 over 7. So that would be the x coordinate in this situation, okay? So if I want to do the cosine, it would be this over the radius, which is going to be still -4 square root of 3 over 7 over 1, but we wouldn't write that over 1. So if they give you one of the trig functions and you want this second one, you're going to always use the x squared plus y squared is equal to r squared equation to help you out, and you're going to use the idea that the sine of x, and let's see, we'll just make sure that we get all those in one spot at the end of this video as kind of a summary. Just going to get rid of all this thing here. Right here. So what do we know? We know that for a unit circle, or for a circle, x squared plus y squared is equal to r squared. If we rotate theta, we know that the sine of the angle of rotation is equal to the y coordinate over the radius, and we know the cosine of theta is equal to the x over the radius. I'm going to let it up to you. What is the tangent of theta going to equal? It's adjacent over hypotenuse. Pause the video, draw it out. Okay, now you're back. So you're right, opposite is going to be the y, and the adjacent is going to be the x. So the tangent is going to be y over x. All right, so there we go. There's the unit circle and the circles and trig, or circle trig as I like to call it. We're going to end this meeting. See you later.